project we're working on together with VRM and the University of Hull is looking at the impact of green infrastructure assets, so trees, parks, etc., on urban heat island areas. And the reason for this is that green infrastructure is a relatively low cost and effective way of helping to mitigate the effects of urban heat islands, mainly through shade and natural cooling through transpiration. So the project itself is funded through Innovate UK and involves a group of partners in Shanghai as well. I've got a pointer, but I'm not sure which slide to point at. Anyway, not this screen. So what we're doing is working with VRM and the University of Hull to gather data on areas with green infrastructure within urban heat island areas to try and visualise and understand the impact that these assets have on the local microclimates. And ultimately, VRM will definitely, Neill, produce an app and a software platform that will be of use to a wide range of stakeholders, be it citizens in and around those areas or potentially urban planners as well. The University of Hull have got some really impressive advanced spectrometry equipment, which Chris will attest to is quite difficult to understand to begin with, but they've explained it all. It's really impressive, measures very accurately surface emissivity and surface heat as well. And our part of this is to do some data analysis on the environmental data that's collected, and also to produce an interactive design guide for people developing buildings in those areas so they can understand the potential benefits of integrating green infrastructure in their buildings. So I'm kind of, it seems a bit odd, by the way, talking about urban heat islands on a very drizzly, quite cold day in Dublin, but I thought that I would set about explaining what urban heat islands are for the benefits of those people who don't necessarily know what they are. I'm sure you've all probably heard of them in some capacity, but they are effectively the inadvertent modification of the localised climate caused by changes to the form, function and composition of land surface and atmosphere. The urban heat island intensity, which is another good term to understand in this, is essentially the difference in temperature between the urban area and the non-developed areas on the external, so the rural areas around it. To explain the effects, it's important to know what we're talking about in scales here. So effectively the macro scale is our climate, the meso scale or the medium scale is the city and its surrounding areas, and then you've got the micro scale, which is the city and the canyons and buildings within it. And I'm going to explain how the mesoscale and the microscale bits sort of work together. It's easiest to explain the microscale first. Bear with me, there's a lot going on in this diagram, but essentially what you've got here is a fairly complicated thermodynamic problem. It all starts with the sun. You've got the sun emitting shortwave radiation, and that's absorbed by buildings, and that is then transferred into heat, so it's conduction, convection, etc. You've got a lot of thermal mass in your urban environments. You've got a lot of dense concrete. You've also got lots of surfaces that don't really reflect much of the heat as well, so you've got low albedo surfaces, which means they absorb most of the heat rather than reflect it. And you've also got other things happening like urban canyons, so you can see there the little sort of circular arrows where you can have effects where wind is flowing over those canyons and actually traps the heat in those canyons. The opposite thing can happen if the wind is blowing down the canyon, it can clear it out. So you've got a lot going on, but one of the other important things to understand here as well is you've got your shortwave radiation coming down, that's absorbed by the buildings. They will then emit long-wave radiation, which if it goes up into the sky, that's great, it's kind of clearing some of that heat out. If it doesn't, and it transfers within the buildings, then it's exacerbating the problem. But you've also got benefits from blue and green infrastructure through transpiration, which is basically plants sweating and releasing heat, and evaporation from blue infrastructure as well. So green, blue, very good at absorbing heat and then emitting it relatively quickly. Grey stuff, black stuff, really slow at emitting it quickly. Really slow at emitting it, that doesn't make sense, but you get the point. at the medium scale, you've got a situation where essentially the boundary layers that we refer to, so the rural boundary layer, the urban boundary layer, and then an urban canopy layer, are kind of trapping that heat in. So the natural flow, the climate, the wind around it, can result in that actual sort of microclimate of the urban area or the urban canopy layer capturing some of that heat. And then these are basically the characteristics of what's happening. So you will get fairly similar rises and falls in surface temperatures in between the rural and air temperature between the rural areas. But what you can see here is you've got similar temperatures in the day for the air, right? But this is essentially a major nighttime problem, because what happens is in the countryside or in the rural areas where you've got lots of green and blue infrastructure, they release heat much more easily during the night time, right? And what happens in the dense urban areas is they retain that heat, which means it's very difficult to cool down at any stage at all. And that has lots of implications for cooling energy, comfort, etc. It would be remiss of me to carry on without noting the chap that actually piqued my interest in this to begin with is a guy called Professor Geoffrey Levermore from the University of Manchester. He was part of the authorship for the International Panel on Climate Change and all those sorts of reports that you've seen. He did some really cool stuff in Manchester where he essentially set out temperature sensors in radii throughout the city, and the chart that you can see there is the temperatures going out in miles away from the centre on the different tangents, right? And the dark blue line that dips there actually coincides with a great big park in the north of Manchester called Heaton Park, for any of you familiar with the city. So he was able to show where there were large areas of green and blue infrastructure that they were able to cool things down. But what we don't know completely so far is how localised those effects are. So well, big parks obviously have an effect, but as Eric was talking about earlier on, you've got some sort of small micro-scale things going on that can actually have a direct effect on people's comfort. So we haven't been working on this project very long, right? We're just 6 months now, is it? Which seems quite long, I suppose, but it doesn't to me. And part of the work we've done so far is to go through a structured literature review process. So what we've looked at is to find all of the literature out there that's looking at urban heat islands, buildings and green infrastructure. And we've gone on to categorise those, so we've basically gone through a screening process and ended up with 744. So there is a lot of work on this already, right? It's not a new thing. And again, as Eric pointed out, this goes back decades, right? People have understood this for a long time, but we haven't really dealt with the problems at all. As part of this work, we've categorised the research into different areas, such as urban heat island characteristics, building integrated vegetation, etc. And what we will use this to do is to try and underpin the design guide that we're working on with GIAUrban to have a sort of interactive map of the city, 3D map of the city, where you can start to understand what benefits you might be able to get from a green wall, for instance, or a green roof. This is just a plot of the amount of research available on this. We've had a massive peak, right? Lots of that is to do with the wide-ranging availability of Landsat data, right? So loads of this work is from urban geographers, people like that, who've now got access to very big data sets that are openly available. And there's just a cumulative version of the same thing showing us that we've got quite a lot to go at so far for this project. Global map of where it's all happening. We've probably got a sort of disproportionate density of these in Europe and in particularly the UK, which London suffers pretty badly. I don't imagine loads of cities, anyone who's from the UK probably is dreaming of having an urban heat island. But yeah, what you can see there I think would probably be reflected if you mapped the amount of universities in those areas as well, to be honest. So it's where people have had the available time and resources to do these studies. But there are some of the usual suspects like Rome and Athens and places like that where you'd expect to see more work in this area. And of particular relevance to us, there's been quite a lot of work in China and Shanghai in particular, which is where our Chinese partners are based. And then we've gone a little stage further to try and start categorising these papers and to take out the sort of metadata, if you like. So what are the key points for each paper? If it's talking about a green wall, how much is it saying it'll cool things down by it? That sort of thing. And by going through this process, relatively long process by the way, this hasn't been easy, we'll get to the end where we've actually summarised this into some numbers that are useful for a tool that GIAUrban are going to develop over time. And that's just an example of how we can drill down and get to sort of location-specific things. Now, this work is obviously kind of secondary research, right? It's work that other people have done already. And this will be supplemented by the collection of our own data. So we've got people looking at the Landsat data already. That can be difficult to interpret. So a good example of that is you've got your normal visual channel on the left-hand side, and then you've got the surface temperatures. And you can see the little white bits there are clouds. They're very cold compared to a city. So you have to be quite careful when analysing this data that you're not saying, oh, look, it's cold near the park, when actually it's just a big group of clouds. We've also started to look at bits of data that's available around Leeds itself. This, again, I emphasise, Leeds is not the hottest city in the world. However, we've got the data available, and it's just a good way for us to sort of test the concept, right? So we're not saying this is a real big problem here, but we're saying that this is how we will go about analysing this data in future. Oh, and by the way, we've got this on our doorstep. We've looked at some examples. So you've got the yellow dot in the middle, that's our own weather station on top of our building that's pretty much in the centre of Leeds. Then you've got a Headingley campus, which is much more leafy, and two sort of less dense urban sites on the south of Leeds there. And when we look at some comparisons, so these are the two sites. Sorry, I've missed the years off, but that's 2015 and 2016. And what we see is that the orange line represents the more rural sites, right? So they are cooling down more effectively overnight, but then they're heating up slightly quicker during the day. But as soon as the air temperature externally starts to fall and the sun goes away, they're able to release their heat much quicker. And that's essentially what we're seeing there. So they're just averages for the summer periods from those years. And you can see it a bit more effectively in this carpet plot, where effectively this maps the urban heat island intensity, so i.e. the difference between the dense urban and the rural. And you can see there that's that kind of pattern repeated that we saw in the previous charts. How are we doing for time? Right, okay. Well, totally. Just my bit. Oh God, right, okay. This is comparison for the city to Headingley. I'm not as confident about this data as I am the other, right? Because it's just a constant difference, which makes me suspicious. Makes me think, is the sensor slightly higher shaded? I'm not sure. But emphasises how important it is to know the quality of the data is good. That's the intensity again. I'm going to race through so Neill's got some time. We've also looked at mapping some pollution data, which we hoped, this is all freely available by the way for London, we hoped this data modelling, so it's data modelling, not physical law-driven modelling, would help us to predict what areas would be more intense in terms of the heat island intensity. However, our data scientist reliably tells me that there is no direct relationship, right? But it's not as straightforward as we might think, because you get things happening like this, where you get inversion layers. So warm air rises, we all kind of know that, but sometimes you get meteorological conditions that mean you can trap cold air in, and then that can make the pollution worse, or even better on certain days, depending on the city. And the same thing goes for where it is, right? If it's right by the coast, you can get this effect. So you've essentially got the offshore breeze, and that can be slowed down by a city. So you've got lots of stuff going on, so we're not pretending this is a simple problem and it will be solved overnight. And that leads me seamlessly into Neill's bit.
I think I've got 1 minute.
Sorry.
Hello everybody, Neill Ryan, so from GIAUrban. I'm going to skip through some of these just to save time. Essentially we're a software company. We have two main platforms that we use in various EU and UK funded programs. The first one is about making sure in terms of compliance what gets done in terms of construction, new build, passive house type stuff, modular build and retrofit happens to the specified directions and plans. And the second, which is the main platform, it's called Clarity, is around viewing information, so a visualization platform to inspect and view data mainly in 3D. And I'll show you that in 2 seconds. I'm going to skip through some of this work. Some of the things we're doing at the moment, we're in our last stage of a project called Built to Spec, which was one of the first in the built environment for Horizon 2020. Most of our projects, certainly on the EU side, would involve 19 to 25 partners from 9, 10 EU type countries. They're all sort of large scale, they're all running over 3 to 4 years. So we have an Irish company and a UK company. Our UK company obviously then looks at Innovate UK with partners like Leeds Beckett, and we're focused on specific tasks and problems where we're able as an SME to lead these type of applications. I'll skip through what we do and how we do it. So just on the project side, so our core business is actually visualizing decentralized energy systems, so district heat and communal heating systems. So we cover already about 7% of the UK with our current contracts. We take in all sorts of data, either it exists, it's in BMS type format, we've got AMR type data from meters, we're adding sensors, and we're taking in manual files, all sorts of ways to then visualize the information. And what we do is we create 3D landscapes of the various towns, cities that we're involved in. And that whole idea then is to, on top of the GIAUrban project, to take point cloud data that we're going to get from Hull and to present that on the map and to be able to visualize it. That's first slides up there. The whole idea of this is to visualize the point cloud located. So we want to see the mass, we want to see what it contains, we want to see potentially where it emanates from, we want to see how far it goes, what areas it covers and so on. But the big thing is to understand what's in it. So the idea then is that we're looking at building physics, we're looking at the pollution and particulate levels that apply to that localized area. Our goal then is to sell this solution to city planners, to developers and other interested parties to be able to see if they put their building in place, and we look at the type of building, a BIM model could be imported for instance. We look to see how green infrastructure assets around or on that building, and they could be green stuff. We're looking at special solutions that you can apply to concrete, etc. So there's all sorts of things we're looking at. This is the library Jim referred to. And the goal for us then out of this is to automatically suggest a short list of the particular types of measures that will most effectively counteract the particular pollution, gases and particulates in that area, and therefore put an onus back on the developers to do something as the planners have this information available to them. Some of the things I'm going to skip over, Jim kind of covered everything nicely on this side, but essentially we have two sides to it. So we have a business commercial angle that we're looking at, and we want to sell this platform. Some shared IP obviously with our partners, shared commercial agreements, so we very much work with academia in that they make revenue out of this as we make revenue from the commercial angle. But then we've got the social angle, so we have to build a mobile app for citizens where that data is freely available. So we're working with UK 100 at the moment, a couple of sites Jim mentioned for pilots, but the idea is we're only working with the cities and areas that are willing to share data, that are happy once that data shows there is issues for that data to be shared and therefore the learnings to be shared. Making that data, some of it available over a mobile app and a portal for local residents particularly to look at what areas should I avoid, what are the best walking routes, how are my kids' schools affected, what's going on there. And then the cities and the planners have the opportunity to show, well, these are the things that are happening, coming in the future based on those planning applications that hopefully will involve green infrastructure assets to counteract those local problems. This one is particularly interesting. So we use M&V built into the system. We work with a company called EEVS in London, and they specialize in measurement and verification. So we're embedding IPMVP as the standard for measurement and verification. We use it for energy now. In the new project, we're going to use it for pollution and particulates. So we're going to evidence what's there now, have independent sign-off via this part of the solution, and then show how the green infrastructure assets are counteracting that proven and irrefutable in the case of it's being signed off by independent bodies and good enough for somebody not to come back on and claim, the information that went into this system isn't good enough. So the big thing is Hull providing their sensors, spectrometry. We're looking at independent, multiple sources of data that are already existing from different types of sensors. We're adding our own sensors to, Croydon, Camden, those types of places. So it's not just the one type of data stream. We have to have multiple data streams. We're then looking to sensitize that data. We're looking to make sure that it's a solid stream of information that we can rely on and use this M&V process inside what we're doing. We're taking this through to a whole lot of different types of projects that we're working on, but the whole idea is that we're trying to reduce carbon in terms of energy and obviously pollution now in terms of the urban heat island effect. I'll skip through some of these because Jim covered it and I know we're out of time. So thanks very much for having us. If anybody wants to talk, that's my details, and I'm happy to talk to anyone afterwards. Thank you very much.